Okay, everyone. I'm just happy to actually talk about Megalodon Shark and the facts and also fiction regarding this. And I was lucky to find on the internet all these stamps with the Megalodon Shark on it. And I actually found out just a few days ago, you just can't say Megalodon because there actually is a clam that's called Megalodon. So from now on, I'm going to refer to it as Megalodon Shark to make the distinction between the two. Okay. So when did the sharks appear in Earth history? And so they appeared. Just one moment. I just have something that's in front of me right here. Okay. Okay, and they appeared about 375 million years ago in the Devonian period. And here's the area just to show you on the geologic time scale where the Devonian period is. So this is the Paleozoic, Mesozoic, and Cenozoic. So sharks have appeared early in the geological history, and their body shape has been very successful, and they survived all the major extinctions, including the past surpassing that of the dinosaurs, and they're still around today. Okay, so this is the primitive shark, Cladius lakei, and so it's one of the first Devonian sharks, and you can just look at it. It's so well studied, and preservation is remarkable. You can see actually the skeletons, and you also notice the skeleton. There's backbone here, and there's also supports in the fins, but there are no ribs. And this is a common thing with sharks. Sharks don't have ribs. And also, in order for them to breathe, they actually have not a gill cover, but actually gill slits along the side. But the basic form of sharks is very similar to what you see in today's sharks. So it's a very successful design that hasn't changed that much for almost like 400 million years. Okay, now here's another shows you a large placoderm primitive types of armored fish called Dunkleotis chasing after some Cladocellaceae about 350 million years ago. So even though they see the sharks, they're quite small at the time, there were other predatory fish that would go after them. But sharks didn't stay in this sort of basic form. They started to evolving, changing in variety of shapes. And so here's a Stethacanthus from Lake Devonian. And so 375 million years ago. And so this is a very odd shark because its dorsal fin has this plate covered with teeth on top. And then there's also some more teeth along the head. And so this is a very bizarre structure. Who knows what they actually use it. It still sort of remains unknown as what the function of this these plates with teeth on them. Here's one, Pelacanthus. It's a freshwater shark from the Carboniferous period. And so this is actually one that's very easily recognizable because it has sort of very slender type of streamlined type of tail with this large point at its end. And so it just was strictly living in fresh water. And so we do have freshwater sharks today, mainly they're bull sharks, and they can easily live and from living in the ocean and change to freshwater, but they need adjustments to do that. And so some of the tropical areas contain, let's say, bull sharks living in lakes and also fresh waters. And so this showed you some Eugenidont sharks in the artist's illustration by Ray Troll. If you ever actually see Ray Troll's artwork, it's very recognizable. It's that style. And so he has actually 2 books on prehistoric life. And so he does show, let's see, pictures of prehistoric sharks in the books. And so these were sharks that would live in the Carboniferous to Permian period. And just recently I heard, let's see, these eugeneodontid sharks are more closely related to chimerids. Those are the ratfish, which I'll explain to you a little bit later on. Okay, and some of you remember, let's see, last time I was talking about some of the fossils here in BC, and so these are, again, the Wapiti Lake fossils, and these are Triassic sharks. And so there's a variety of types of sharks, including undescribed species, but they're just amazing preservations. You can actually see the outlines and the dorsal fins, and also the bottom fins of all these sharks. This one here shows you the tail fin. And so just amazing preservation, but this is not the only place we can find well-preserved shark remains. They can also be found in other places too, where the remains of sharks are really well preserved. So we actually see the outlines of the sharks and get a good idea of how they look. Okay, at my time in Vancouver Aquarium, I taught the fish course to the volunteers that were there. And so this is a really simplified grouping of the fish. And so we have the cartilaginous fish, in which contains the sharks. And those ones, their entire skeleton would be made of cartilage, or cartilage that reinforced with bone material. And then we have the bony fish, which their bodies would be made of true bone. And so there'd be some that are slightly cartilaginous, but they're still regarded as bony fish. So most of the fish that we are familiar with today, most of them will be bony fish. And then there's the jawless fish, represented by having sort of almost like a notochord, which is sort of a flexible rod that runs through their body to keep their body supported. And there's only 2 types of jawless fish that exist today. In the past, they were quite abundant and diverse. And so the ones that are here today, these are the hagfish and the lamprey, which we both, they both live on our coast. Okay, so of the groups of the cartilaginous fish, we have the sharks, the dogfish, cat sharks, porbeagles, great white sharks are also there, hammerhead sharks are there. So that's all the sharks that are belong to that group. Then we have the stingrays and the manta rays, and anything that are rays would be in one group, and these tend to be very flat. Sometimes they have a barb at the tail, and sometimes not, like the manta ray. And so they have their eyes on top of their body. Similar, they're the skates, not the Canuck ones, but skates, the fish. And same type of thing with like the rays, but they have more pointed snout than the rays, because rays generally have rounded ones. And also they have little fins on their tails, which makes them very distinct from the rays. So we get a lot of people that get the confusion of skates and also rays, and it's not an easy thing to distinguish the two unless, let's see, you really look hard and try to separate the 2 groups. So the other group here is a weird type of group of cartilaginous fish. And so it includes the chimerids, ratfish, ghost sharks, and rabbitfish. And there's example one that we have at the aquarium is the ratfish. And so all these fish, they have cartilaginous skeletons. In fact, let's see, I remember with doing my dogfish dissection, you can actually use a scalpel and actually shave off the top of the skull to actually get to the brain. So it's just like the cartilage, like the material that you find in your kneecaps, in your joints. So it's white, smooth, and you can actually just easily cut through it with a scalpel blade. And so that's what most of their skeleton is made of, except for the jaws of these fish. And so which they've been sort of like calcified with bone material. And so it makes it more hard and durable. And their teeth are also covered by dentine and enamel here to give them strength too. Okay, here shows you a model of internal anatomy of a great white shark. Okay, and we have here the brain, and the brain is actually in a cartilaginous skull, which is called the coronal cranium too. And so that's all cartilage there. And then we have a number of gills behind the head there, and these would be shown on the outside through gill slits. And then we have the jaws loaded with teeth, or sometimes they might have plates if you're a bottom feeding type of cartilaginous fish. And so these ones would be all calcified, they'd strengthened with bone material to add strength, and same with the teeth. Enamel and also dentine to actually strengthen the teeth. Also behind, underneath the heart, the gills right here would be the heart. And so the oxygenated blood would go to the heart and then transfer across the body. Now, the big organ that would cover all of this, all the inner organs, would be the liver. All sharks have this large, enormous liver, and they need that to keep themselves buoyant. And so that liver would be filled with oil. And so underneath, when you remove the liver, is a stomach right over here. And the stomach goes into the intestine, and the intestine, like in us, is sort of like a tube. But they have in sharks and all the cartilaginous fish, and even some of the primitive bony fish, they have a spiral valve. It's sort of almost like a corkscrew in the stomach, in which is almost like intestine, but everything goes through a sort of a corkscrew and comes out the other end. So it's almost equivalent to our intestines, where being absorbing a lot of material that come from the stomach. Also, we have reproductive organs right over here. And so because it's a female shark, it's ovaries. And another way to actually also figure out this is a female or male shark is you look on here and there'd be long extensions. Those are claspers, which are showing on male sharks. And you can also do it with the ratfish, the rays, and also the skates. And it's easy to tell, let's see, which is male and which is female, because only the males have the claspers. And sometimes when the fish are actually live born and quite early in their life cycle, they already have their claspers already showing. Okay, here's just show you some of the things that we know about some of the fossil sharks. And one thing is that we have lots of shark teeth. And anyone who actually saw Dan Bowen's talk on the sharks of Hornby Island, a lot of his collections and things that he's shown were actually shark teeth. And so this is one from Brennan's collection, a picture of his display. And so he has cataloged all his shark teeth along here. And what's interesting is the sand tiger sharks, the lemon sharks, the mako sharks, even great white sharks, they're still around today. And you can actually take a ordinary book, let's see, today's sharks, and you can actually use them to actually key out and identify some of the fossil sharks, because they're only something like several million years old. And so these ones are probably coming up from the Miocene. And so they're easy actually to distinguish just with a modern shark book that shows you shark teeth. Okay, these are some of the fossil shark teeth that I had at the aquarium. And so there's a variety here that show you the variety types that are in the ancient oceans, including Megalodon, Megalodon teeth here. Okay, and they're just small ones. Okay, here's shows you shark teeth collection. They get on a postcard from Venice, Florida. And so we do have modern bull shark jaws with Carcharodon, Megalodon on both sides, with extinct sharks that you can find today. And on the top, there's fossil shark teeth. Now, besides teeth of some of the sharks, you can also find vertebrae of fossil sharks in the fossil record. And so this is, it shows you the vertebrae, some recent sharks, and they're very similar to the ones that you find in the fossils. They look like stacks of coins. Okay, a little bit thing about the story about fossil shark teeth. During the Renaissance period, they were regarded as a source from petrified tongues or petrae from dragons or snakes. So there are the tongues of these ancient snakes or dragons, and that's what they believed. And today we think of that being sort of a foolish thing, but people then want to explain what the sources of these fossils were. And so there's things like ammonites, which they believe at the time were petrified snakes. In fact, some of the people actually carved on the ammonites fossils the heads of snakes, and so people believed in that. Okay, and then in 1667, Nicholas Steno, which was a Danish naturalist, he got a head of a shark, and he described it in his text called "The Head of a Shark Dissected." And looking at the teeth here, they're definitely from a great white shark. And so one thing he established looking at the dissected head was all those petrified tongues were actually shark teeth. And here we have one, the great white shark. And you see the teeth that are being used, but also underneath them, there's like rows of teeth that are underneath the skin. And so if one tooth gets lost, it's replaced by another tooth. Same with the nurse shark here, rows and rows of teeth. And same with the silky shark, one tooth disappears, gets lost, and it's replaced by another one. So I always joke with the kids at the aquarium that say that the sharks don't have to go see the dentist. But with these rows and rows of teeth, they would constantly have losing teeth, and these would actually become part of the fossil record. The other thing is also, since the nurse shark teeth and the silky shark teeth, the silky sharks tend to be pointed, while nurse sharks are more blunt, and that's because they live and feed on things on the bottom. Silky sharks are pointed, so they feed on fish. So the teeth show you a little bit idea of what the function of the animals and what they ate. The great white shark jaw here is more conical here, and so that's adapted to eating marine mammals. So I actually had a really lucky time to actually, when I was at the aquarium, to see a juvenile replica of a great white shark, and their teeth are totally different. They're more pointed like the silky shark. So when they're quite young, these young great white sharks are feeding on fish, and when they get older, they switch over to marine mammals. So in 1843, it was Louis Agassiz, which was a Swiss naturalist, noticed that these large shark teeth that people will find, the fossilized ones, look very similar to great white shark's tooth. And so he gave the name of these teeth, Carcharodon Megalodon, which is stuck onto since till very recently. And he described it in his text of Recherche sur les poissons fossiles. And so he described it in there. And this shows you me standing by a real great white shark jaw at the Vancouver Aquarium. And you can see actually the conical sort of triangular shaped teeth there. And so this individual came from Australia, and the description was it was about 5.1 meters long, this individual. And so there's a scientific name of the great white shark, Megalodon Sharks. And so that's a scientific name of the great white. So a Megalodon is, it shows you a connection between that and Megalodon, but that is debatable. You also notice that this shark jaw is missing 3 of its teeth in the front. And so that was due to an accident where this shark was displayed in a room, and it was attached with a safety clip. And eventually someone bumped their head on this, and this thing actually landed on top of the person's neck. And so the aquarium actually had to call in the ambulance, and so they take the person. So he actually got a few stitches when the shark jaw fell on his head. And so this is why this whole container shark jaw is actually in this display case to prevent any more injuries. And my time at the aquarium, I actually recorded two other injuries done by this shark jaw. And those shark teeth, they are very sharp. I never realized that, and came with the idea of actually putting in this case, which unfortunately makes this jaw of moving around very cumbersome and awkward. But if you can do it, if you get 2 people to actually help out, it can be done. But I was just thinking to myself, for the protection of the volunteers and staff, I think this should actually belong in the case, which is still in there. It's an impressive specimen. And like I showed before at the beginning, there's a picture of me with Megalodon shark tooth compared to that of the great white shark tooth here. And so that's my office at the aquarium. You can see the difference between and somewhat similarities just by looking at them, triangular type teeth. Okay, these are more Megalodon shark teeth. And so this is actually the one on the left here. This is the first one I actually saw when I started volunteering at the aquarium. So I've kept that in the collection and sort of made replicas of this and kept the original with me. There's no information about where it came from or any other details, but you actually, you can see the height of this tooth is about 14 centimeters, same with the one on the right too. And with this replica, a really nice one, I got it from Skulls Unlimited. I had several of them purchased for people that want to talk, both the staff and also volunteers at the aquarium. So give a good example of idea of actually how big these sharks are. It was especially really helpful during Shark Week, and so when people want to learn something a little bit about the prehistoric history of sharks. Okay, so when did Megalodon live in Earth's history? So we have a geological time scale here, and so they lived 2 million years ago to about 2.6 million years. Okay, so in the Cenozoic, and so that's probably from the Miocene to the Pliocene. That's right before the Pleistocene, the Ice Age. Okay, and this shows you Megalodon sharks fossil localities. So during the Miocene, the Earth looked very similar to what you see today, with some differences in it, but not majority. All the continents remain pretty much what they are today. So a lot of these sites where you find fossil localities, they are sort of like in tropical or semi-tropical areas. And so it shows you that Megalodon was definitely a shark that lived in warm waters. And so it frequented in those waters and also hunted for its prey too. Okay, so in 1909, Basford Dean, working for the American Museum of Natural History in New York, wanted to make a jaws based on some of the teeth. And so he had made the first reconstruction of the Megalodon shark, and he based it mostly on large teeth, and also he didn't actually. He only had like not a complete set of teeth. He used teeth from a variety of other source, and so there's actually too many teeth in the jaws, and the jaws actually turned out to be enormous. You can actually see from this, and so the shark at this size would have been maybe uh, about 100 feet long, and so people believed that this monstrous shark in prehistoric times existed. And I remember, as a volunteer, I remember this shark was described. It was actually capable of actually swallowing an entire bus. And so there is a lot of things that we didn't get exactly correct. And so it was up to the paleontologist to re-examine the shark. Okay, and so what paleontologists have done is they've actually sort of made a correlation between two types of characters you can actually find on the tooth to give you a rough idea of the estimate size of the sharks. And so the first one, you can use the enamel height of the tooth. And so this is the enamel right here, just covering it. Yeah. And so the rest of this would be covered by the flesh of the fish. And so just by doing the enamel, you can actually put it into a formula and just shows you a rough estimate of the length of the shark. Or the other idea was also using the root width of the tooth. And again, this would all be buried underneath the flesh in the jaws. And so you can use that to estimate the size of the shark. And so in 1985, Smithsonian Institute in Washington made a more accurate type of Megalodon shark jaw too, and they had like partial, complete teeth that had been preserved, and so they were able to actually figure it out. And you now see a much more smaller version of the jaw. And I actually communicated, I sent to one of the paleontologists that put this thing together. He said, let's see, it took a little bit more accuracy, and I got sort of the information about how it was all put together, and asked him about this picture on the right, like who was involved with that. And so he actually, I remember him saying that, see, a lot of people that you see in the picture weren't even involved in this project, but it is probably the most accurate jaw of Megalodon shark. Okay, and so it's now smaller than you actually seen before, but doesn't make it less interesting. It's very interesting shark. Okay, and so this shows you one Megalodon shark jaw that was actually at the Tellus World of Science for the Ripley's Believe It or Not exhibit. And so here I am standing inside of it, and so it gives you a good idea how big the shark jaws are. And I have other ones. Here's one, let's see, Megalodon shark wall painting. This is permanently at Science World. And so if you go to the Sarah Stern Gallery in the back there, you'll see all these sharks' jaws on the wall. So first big one, there's the Megalodon shark jaw. And there's me showing you the size of it. And then there's the great white shark jaw, followed by a silky shark. And then there's a small one here, which it took me a long time to think it out, because it didn't look like a dogfish. So I think it's maybe a brown cat shark. And that makes sense because brown cat sharks, they're the smallest sharks that we get out here in the BC coast. But again, this is permanently in the Sarah Stern Gallery. If you ever a chance to get to Tellus World of Science here in Vancouver, and you can actually see this. Here's one Megalodon shark jaw there in Denver Downtown Aquarium, and also at Point Defiant Zoo and Aquarium. So it is quite exciting actually seeing the jaws here, because I remember seeing them a long time ago, but never had a really great picture. So I have nice pictures of me beside the jaws. And so it's just a wonderful thing to actually see this shark on display, even the jaws. Okay, this shows you a little bit of teeth. So the largest Megalodon shark tooth is about roughly about it exceeds 18 centimeters, about more than 5 inches in height. And here's a picture of one from Graham Ellis's book on shark, large fish, and so there's my hand there to show you how big it is. And I've seen on the website the other teeth, and I think people do it with photographic tricks and showing the teeth almost like a foot long, and even enormous ones. Like there are people holding on with both hands, and so as far as I know, the teeth don't get that big. And so here's my hand to actually show you how big the teeth on average get, just roughly. So these are the largest teeth, but they're just on average. And so Megalodon is usually pictured as a giant uh, great white shark. And so that's the common thing because of triangular shaped teeth. And so they think this is what it looked like. And here's also shows you some pictures of Megalodon sharks, and this was from Jacques Cousteau and Philippe Cousteau's the shark, the splendid savage of the sea, showing the sea how they'd be compared if to a person and divers. And so they also show you to see the great white shark tooth and also the Megalodon tooth. And so you can actually see. So in this type of the illustration shows you so that the Megalodon shark looks almost like a bull shark. Okay, and here's another illustration of Megalodon shark from Life Before Man. Okay, again, let's see, very similar type of great white looking. This is Richard Ellis' book, Big Fish. Richard Ellis actually wrote a book on sea monsters and also mentions Megalodon shark. And people should actually, if they want to know a little bit about the history of the Megalodon shark, it's actually written up in there. And he does a really great job of talking about Megalodon, and he does a great job on the giant squid too. But the Megalodon, he talks about a little bit about the mysteries and also the fictitious material that came out from this Megalodon. And so you get the idea that he might be a believer in all this, but no, he's actually repeating the history of the Megalodon shark. And so here shows the Megalodon shark compared to a diver of the great white right here. Okay, that's the great white shark. Okay, and this shows you a size relationship to a person here. So the largest great white shark on record is about 6.1 meters in length. Okay, the whale shark, it's the largest shark fish in the world that's actually living. So it's about 12.6 meter in size. And we do get a large shark on our BC coast. They used to be quite abundant, but they've been reduced to small number. That's the basking shark. And so it's a little slightly smaller than the whale shark, but people occasionally actually see them in our waters. They're very abundant off the coast of Europe there. And this shows you a conservative measurement of Megalodon shark, which is, they estimate, about 15 meters, okay, or 43 feet, okay. And the maximum it's come up is like 18 meters or 59 feet. So those are two schools based on. So that this shark is no longer 100 feet or 30 meters in size. It's been reduced to like maybe 15 to 18 meters. And so because sharks, when they get preserved, they're made of cartilage, so it doesn't preserve very well in the fossil records. This is why, let's see, they sort of like can only estimate. There's been no, as far as I know, Megalodon shark fossil complete skeletons that ever been found. It's always been sort of very partial on vertebrates and also teeth, and that's all the information they have. And so there's been a lot of development of actually people reconstructing the shark based on new evidence. And so this is one of the new evidence that came up that maybe that it is the shark is related to sand tiger sharks or the gray nurse sharks. And so we had one at the aquarium a long time ago. So this is maybe sort of like, it would be a sort of beefed up version of a sand tiger shark. Then the other option is our basking shark here. I should mention that the sand tiger shark is today's is actually a fish eater, while the basking shark, which is the second world's largest shark, is a plankton feeder. So they have their gills developed into rakers, so they can actually feed on plankton in the water. I've never seen a live basking shark, but very few people that I know have actually seen this. So there's not too many sightings when there used to be historically very abundant here on the West Coast. So these are the two images. It's either like the sand tiger shark, or let's see, a basking shark, or the great white shark. So we're not sure because we don't have a lot of skeletal remains in the fossil record for this shark. Okay, so what did it feed on? So what it fed on is marine mammals, seals and sea lions and sea turtles, and anything that actually went swimming in the water was actually fair game for these sharks. And so the juvenile Megalodon sharks, they had same types of teeth as the adult, except they're smaller, so they most likely fed on seals and also sea lions at a young age. I also should mention that during this time when the sharks were around, there are also large predatory whales that also existed and probably also competed with the Megalodon sharks. And I wouldn't be surprised to see if the Megalodon sharks became some of the food sources for these large marine mammals that existed at the time. But just remember, a lot of the whales that existed at the Miocene time and throughout history up to Pliocene were small, not like the big ones that you see today. So most of the cetaceans, the whales, tend to be maybe about 10 meters in size maximum. Okay, there was also all these things like dolphins and porpoises that would also been fair game for some of the medium-sized Megalodon sharks too. And this shows you at the time during the Miocene, Megalodon sharks, they live with other modern types of sharks. And so some of the ones that you see today are very similar to the ones you see today. So they haven't changed much in the Miocene. And this shows you the evolution of the Megalodon shark. And so you'll see, if you go on any websites, Carcharodon megalodons, that's a common name, let's see now. But there's also a Carcharorhocos megalodon, okay, that's a different type. And they're all talking about the same type of shark. And there's also a Totus, and also Megasalactus megalodon, okay? And they're all talking about the same Megalodon shark. They just have a different scientific name, because the problem is, let's see, there's a lot of sort of debate about where the shark originated. So one is from the Cretotolamna via Carcharodon origin. So we have this one right over here, Cretotolamna, developed into Carcharodon orientalis. And then you have a variety of Carcharodonts developing here. And then they separate, one becomes Megalodon, and then one becomes the great white shark. And so that's one type of lineage that people have suggested, okay? There's another one here, Cretotolamna via Totus. And here we have again, Cretotolamna right over here, and it separates into a Totus. And then there's Paleocarcharodon. And then you have Carcharorhocos, Reticulatus, and then you have Carcharorhocos here, and then you have Carcharorhocos there, Megalodon. Okay, so that is sort of like another different scenario there that shows you the lineage. So it's not quite clear of where the origins of the shark is, and so more research is actually necessary to sort of filter out and actually clarify where it evolved from. So that's why you always see different names for Megalodon sharks. Okay, I just want to talk a little about the some of the fictitious things about Megalodon. And so this one is, I've heard it before, as Megalodon sharks living in the bottom of the Marianas Trench. And it is actually mentioned in Richard Ellis's book. And I actually had a small debate with one young fellow who was talking about Megalodon sharks, and there's in the bottom of the Challenger Deep and in the Marianas Trench. And so we have been down there. In 1960s, it was the submersible, the Trieste. And so it was sort of like an undersea elevator. And so there was gasoline in there to give it buoyancy. And the passengers were piloted the craft in a hollow sphere here. And it was Don Walsh and Jacques Picard that actually went down to the bottom into the Challenger Deep at 35,800 feet. Okay. And there's been other research vessels that have actually trawled and dredged in these trenches, and there's other trenches all along the sort of like the western part of the Pacific. So the Marianas Trench would be somewhere about right here, close to the island of Guam. And there's not much life there. Most of it tends to be sort of like their tissues are made of water. And so a big, large predatory shark would not be at the bottom of this deep trench. And other remote operating vehicles have visited the Marianas Trench, and also other submersibles. And just recently, the Chinese have actually developed a submersible down to the Challenger Deep, and none of them found any large animals besides, let's see, some of the gelatinous fish and a lot of invertebrates. And so it's unlikely that some large sharks exist there. And then the only deepest shark that's actually on record is probably something about 8,000 feet. And so sharks would not be in the bottom of these deep areas because the food there is not the best quality, especially one that actually developed for eating something like marine mammals. But it's called Challenger because the HSM Challenger did a sounding there and found the water was quite deep. And so it was about 26,850 feet deep. And what's interesting about the Challenger expedition is actually you can go online and actually you can find megalodon teeth that have actually dredged up and retrieved from the bottom of the ocean. And so you can actually go by stations, and they tell you the stations when they're caught, the depth also about where they've been found. And you can also find other shark teeth besides megalodon teeth. And here we have these things called magnesium nodules. And the arrow points to a shark teeth, and it's covered with this magnesium. And also kinds like microscopic animals known as foraminifers, and also whale bones covered with magnesium. And so what I'm getting at is there's also things where the Challenger retrieved this Megalodon shark teeth there, and someone was actually a scientist was able to actually look at that and measured the amount of manganese on the shark tooth, and he came up with something like 11,000 years. And so that was sort of like brought in a little bit of evidence, believing that this shark still existed in present day time. And what they found out later on is, depending on where you are on the sea floor, magnesium deposits out of the seawater at different rates. So it wasn't a really definitive type of way of dating something. And so these samples that you see were just pretty much the magnesium depositing on the shark teeth at a slow rate. Okay, and so this shows you the HSM Challenger collection. You can go to the website and actually see all of these samples that were collated from the 1870s. It's just a remarkable site. And there's the website right over here. And so that's where I was able to get some of the information here. And again, you can just go on one of the sites there. In fact, you can actually look for the site where it is the Challenger Deep there, and you won't come with anything because they really didn't sample there at all. They just did a sounding there, and that was it. You also found out by going through the sampling stations, finding which one's the closest to the Marianas Trench. I mean, none of the teeth are from the Marianas area, nothing. And they're all pretty much in the South Pacific. So all this thing is sort of like misinformation that people have reported. And you still see it in today's website. It's really surprising that you still see it, and that the Megalodon shark tooth was found at the Marianas Trench. And so these just shows you some of the samples that were some closest stations to the Marianas Islands. And so they're all in the South Pacific, way far away from the Marianas area. And again, you can also put in search for all the Megalodon tooth. And so it gives you the same idea. None of them are within the Marianas Islands. One thing I came from, and it's kind of really ridiculous, of some of the stuff you find on social media, where they claim actually they're taking a video. This is a video of a shark, but it's not the Megalodon shark at the Marianas Trench. It's actually a Pacific sleeper shark. And so this one here was almost like a 25 feet in length, or 24, 25 feet in length, okay? And real or fake? Well, it is real. And that cage right there that you see, people thought, it actually posted on this website that it is actually 6 feet by 6 feet, but no, that's only 2 feet by 2 feet. And so this is in Suruga Bay, Japan. And I've actually seen the actual video, and actually I have the magazine from National Geographic showing you this picture. So it's not Megalodon at all. It's actually a Pacific sleeper shark. And so, you know, so you find things on the websites and on social media, some ridiculous types of stuff that crop up. The other thing is also myself and also Brendan, the number of times we've had fossil displays, it's just incredible the number of people and visitors to get when they talk about, you know, Brendan would have his real Megalodon teeth there, and people would say, you know, that they actually believe this fish is still alive. The shark actually lives. And they said, well, you know, we saw it on TV. And they said, that was the Discovery Channel. And I've seen that show, and you know, you could probably look up the scientific names and find out the scientific name of that scientist doesn't exist. You can tell that, see, there was a lot of CG that was added there, a lot of things very fictitious. So, you know, this shark is extinct. It doesn't live today at all. We try to tell the people about this, and you know, some of these people are convinced and argumental to actually believe this sharks, and they're really surprised when you actually tell them it's extinct. One more thing I wanted to add is, you sometimes see this is, the Megalodon lived at the same time as the dinosaurs, and so it's actually a Cretaceous shark. And so it's attacking probably a juvenile mosasaur, so it looks at twice as big as before. And throughout time, there's not only just Megalodon sharks existed. There are also other large sharks that were related to the great white sharks that also were very predaceous too. Okay, I did this presentation at the the Vancouver Gem Show a couple of years ago. And when I finished doing the presentation, I came across this. It's actually a TOTUS Megalodon model. So they've gone, instead of the great white shark, the Carcharodon way of actually picturing the Megalodon shark, they actually use a TOTUS, which is more related to the sand tiger. And so this one's at the Smithsonian Institute, the National Museum of Natural History, that's actually hanging up there right now. And so this is one kind of way that's looking at a different type of view of looking at the Megalodon shark. And so I'd just like to thank you very much, and thanks for all the fish. I'm standing here holding up a jaw of a tiger shark over here. And here I am holding on to a model of a hammerhead shark. And so I didn't find it very heavy. It's actually quite light, but awkward and actually moving. Okay, I'm just going to go through the chat and just see if there's any questions right over here. See, we have a question. Okay, hello.
Perry, there's one, somebody was wondering if there's any other bony parts to the shark, or is it just teeth? For example, are the jaw bones also bony?
No, it's really surprising there aren't any jaw bones. And we have to actually wait and actually see if anyone finds any of the jaw bones. I haven't heard of any. I wouldn't be surprised if people found one. But most of it is teeth and vertebrae. And that's the things that they find. I came across on a website where it looked like it was somewhere in Peru, where they had what looked like the skull of a Megalodon shark, but no more information on that. But what was really funny is the vertebrae that leading away from the skull was extremely small. And the skull looked like it was in a concretion, and there's definitely teeth in there that look like Megalodon. But then again, let's see, that's what the person actually said was a Megalodon shark. And the unfortunate thing is nothing else. There's no more information about it. It's just like put on someone's website. And so,
was that the one